In an obscure museum in Eastern Europe, a fossil hunter has made a momentous discovery. The young paleontologist was randomly sifting through a collection of drawers that hadn't been examined for 30 years.
I was going through these drawers, finding drawer after drawer of very much the sort of fossil I would expect to find, really nothing of any particular excitement. And then, pulling open one drawer, I spotted, in the middle, sitting in a little cardboard tray like so, a fossil the likes of which had never been found anywhere in the world.
Of all the tales of life on Earth, there is one more fabulous than all the others. The story of how we got our legs. Scientists believe that long ago a fish came onto the land, grew legs, and started to walk. It is one of the most crucial events in the history of life, because that animal is our ancestor. But how and why that fish grew legs is one of the biggest mysteries in evolution. It baffled the finest minds in science for over a century. All they had to guide them were the theories of Charles Darwin, evolution's founding father. Darwin said the answer would lie out there in the rocks. Somewhere there would be fossils that would explain everything. Paleontologists would go scurrying all over the world trying to find them. But such early fossils are rare.
There's still so very, very few pieces of evidence. This is like one of those terrible classic murder mysteries, you know, that goes on for 30 or 40 years and people slowly trying to pick up a little bit of evidence, a little bit there.
But the more scientists looked, the more they realized one crucial fossil was missing. This would become a challenge to the whole theory of evolution. And the story of how we got our legs would become the quest for the ultimate missing link. The whole quest began 150 years ago with one simple observation. A vast array of animals are in fact related. They all have 4 legs. They are tetrapods.
We are tetrapods, to wit, 1, 2, 3, 4.
Every mammal, every dog, cat is a tetrapod, 4 legs.
A horse is a tetrapod, evidently enough. So is a bird.
All the reptiles, all the frogs and salamanders, and even the snakes, which don't have legs at all, whales, which don't seem to have legs, they're all tetrapod animals.
Scientists became bewitched by the fact that under the skin, all tetrapods are basically the same. They all had spines kept firm by special interlocking spurs. It is as true of us as it was of the dinosaurs. All tetrapods had a pelvis attached to the backbone to support their weight. They all had a rib cage to protect their heart and lungs. And they all breathed air through nostrils. Their limbs invariably consisted of one single bone at the top, a pair of bones underneath, leading to feet or hands, which scientists noted never seemed to have more than 5 fingers or toes. It was true of dinosaurs, human beings, and even whales, for under their flippers, they have 5 fingers. This similarity convinced scientists all tetrapods must come from just one type of creature, a single common ancestor. To prove it, they thought they needed just 2 fossils. They needed the first tetrapod, the very first land-walking creature with 4 legs with 5 toes. And they needed the fish from which it came, a fish that could grow legs. Find these 2 fossils, compare them, and in the differences between them, we would learn the reason why a fish had developed legs. They had one huge clue to set them off. They knew this evolution must have happened 400 million years ago, in the Devonian era. The Devonian is so long ago that barely any rock can now be found from it, let alone fossils. But academics knew that before it, nothing walked, and after it, everything did. So the evolution of legs must have happened then. And they thought they knew something else. Textbooks said it was a time of blistering heat, when almost nothing could live on the land, not even plants. It meant most life survived not on land, but in the water. This was the age of fish, and one of them, the one with the beginning of legs, was the first fossil they needed to find. Finding that fish fossil proved easy. By the turn of the 19th century, all eyes were on a Devonian group called the lobe fins. Lobe fins uniquely have a bone structure in their fins that seems to be a precursor to our legs and arms. And one particular lobe fin, the long extinct Eusthenopteron, had all the leg bones except the feet and toes.
Here in these fossils, the limb was just laid out simply beautifully, and it was so easy to turn it in your mind into a tetrapod limb. These bones, the 1 and the 2 bones, they were laid out, and there were these bits in the ankle and the wrist and so on. Absolutely fantastic, beautiful material. Clinched it, really.
What they thought they'd clinched was the fish from which we all came, the ancestor without legs. And early last century, scholars developed a theory to explain why it might have evolved legs and started walking. That brutal Devonian sun must have been the cause of droughts. Fish would have been trapped in drying pools and faced death. To survive, a few Eusthenopterons must have dragged themselves on their fins, as mudskippers do today, out of the puddles in search of deeper water. Some could then have evolved on land. Their fins became legs. They grew 5 fingers and toes. They started to walk. They became tetrapods, our ancestors. Limbs had developed so they could do what we all do: walk on land. The drying pools theory seemed to explain everything, both why we had grown our legs and from what we'd evolved. All they needed to confirm it was to find that very first tetrapod, the creature into which the fish had evolved once it was on the land. If it was, as they'd predicted, an animal with 5 fingers and toes, then the whole thing would make sense. Many would seek this mythical beast, and for years, no one found it. In the 1930s, a team of Swedes made a series of trips to Greenland, one of the few places in the world with outcrops of Devonian rock. Their mission? To find that first creature with legs. Among the party, Erik Jarvik. Jarvik's team found what everyone had been searching for. Fossils of the very first creature with legs, rather than fins. They called it Ichthyostega.
People have been looking for this, in a way, ever since Darwin, ever since 1859. This transition is the one that's so intrigued everybody, going from the water to the land and no evidence of it, and then, boom, they found it. Terribly, terribly exciting. Really very, very important.
It fell to Jarvik to analyze and describe the new discovery. This meant years of digging the fossilized bones out of the rock and then trying to reconstruct the anatomy of this strange creature. Jarvik was a brilliant anatomist, but he was also painstaking. He started in 1948, but did not finish until 1996. In those 48 years, no one else was able to analyze the fossil.
To be honest, it shouldn't take that long. I mean, that's... Frankly, I mean, you have to be really sort of anal to take that long to describe anything, especially when the world is just hanging on this.
But Jarvik did produce 2 preliminary papers. These did confirm the existing theory. Ichthyostega was an identikit land-walking tetrapod with 5 fingers and toes. The mystery of how we got our legs was solved. After Eusthenopteron, the fish had struggled on its fins onto land. It had evolved into Ichthyostega, the first tetrapod with legs. It was just as science had predicted. But then, the doubts crept in. Only Jarvik had ever analyzed the Ichthyostega fossil, and you just had to take his word for it. But worse, mutterings began that there was a gaping hole in the story. Eusthenopteron could not be the immediate ancestor of Ichthyostega. The difference between them was too vast. Ichthyostega was a fully formed tetrapod with a rib cage, pelvis attached to the backbone, a spine with interlocking spurs, and limbs with fingers and toes. The fish was still a fish, despite its primitive leg bones. It showed little sign of evolving any of these other tetrapod features. To prove one had become the other, they needed more evidence.
What this really adds up to is that these changes are simply too gross to have happened in one step. There must be missing animals in here.
For a start, somewhere out there should be other species of Devonian tetrapods, which might shed some light on the theory. But above all, they needed to find an intermediate animal, one that showed the changes between fish and tetrapod actually happening. Some strange beast that could walk, but was half fish, half tetrapod. There was a missing link. The missing link had to be what Charles Darwin called a transitional form. These lie at the very heart of his theory of evolution because they show how one animal can mutate into another. Transitions occur in evolution when there is a dramatic environmental change. Creatures that cannot adapt to the new environment die out. But chance mutations often turn out to be the key to survival. There is an explosion of bizarre forms as a host of mutants experiment with living in the new environment. These freaks of nature will die out quickly, and just some will become transitional forms, creatures that are half one animal and half another, which bridge the old way of living and the new. Transitional forms are the most crucial fossils in all evolution.
They're important to the zoologists, to the paleontologists, because they they show you what the process actually was. I think they're very important to the public as being direct evidence that there was a process of change that you can document.
But transitional forms are also the rarest of beasts. By their very nature, they were few in number and lived for just a short intermediate time until a wholly new animal evolved. In fact, for years, there was only one accepted transitional form, the Archaeopteryx, which was a dinosaur with feathers that marked the transition to birds.
Presumably, the transitional forms were very rapidly outcompeted by their own more advanced descendants. So these transitional episodes in the history of life tend to be brief and involve, it seems, relatively low numbers of species and probably low numbers of individuals.
The trouble was, without anything half fish, half tetrapod between Eusthenopteron and Ichthyostega, the story of how we got our legs remained incomplete. And lurking out there was a group dedicated to pointing out such gaps in the story of evolution, with the aim of its ultimate destruction. Duane Gish is a scientist.
My bachelor's degree is chemistry from UCLA, and my doctorate is in biochemistry from the University of California at Berkeley. After I finished my doctorate, I went to Cornell University Medical College for 3 years, where I worked with Dr. Vincent.
He's also a creationist, a believer that the world was created in 6 days, just as it says in the Bible, according to God's plan. And therefore the whole theory of evolution, he thinks, must be wrong.
Evolution has no plan, no purpose, it's a random process.
Creationists believe that all animals were made fully formed by God. One main line of attack is the rarity of transitional forms. If you cannot show how a fish evolved into a tetrapod, then, they argue, evolution never happened at all.
The fossil record is enormously better now than it was in Darwin's time, but it hasn't solved Darwin's problem. In our museums today, we have about 250,000 different fossil species. If evolution is true, tens of thousands of those things should be of obvious intermediates. But they're not there. Every major type of creature appears fully formed, no ancestors and no transitional form.
The irritation for paleontologists was that no one had yet unearthed a transitional form between fish and our earliest ancestor with legs. One just had to be found. And then, for a brief moment, it seemed one had been, when in 1938, a miracle happened. East London, in South Africa. 63 years ago, just before Christmas, the curator of the local museum was idly sifting through a fisherman's catch down on the waterfront. Marjorie Courtney Latimer was then just 31 years old.
22nd of December 1938 was a wonderful day. I came onto this most beautiful fish. It was just on 5 foot. It was silver and gold and green and blue and had white kind of flecks on it. And to my horror, it had these slim-like fins. And I thought to myself, what on earth can this be? I've never seen a fish like this.
She rushed the fish off to have it preserved. Then she asked Dr. J.L.B. Smith, a South African academic, to identify it.
He stood at the head of the table and he said, well, lass, he said, this fish will be on the lips of every scientist in the world. It's a coelacanth.
Coelacanths were a breed of Devonian lobe-finned fish that were thought to have been extinct for over 76 million years.
It was absolutely fantastic because it's living, and it's exactly like having found a live dinosaur or a live Archaeopteryx.
The scientific community was transfixed. For decades, the coelacanth had been touted as a possible transitional form between fish and tetrapods. But no one had really known enough about it. It existed only as a fossil. Smith proclaimed the coelacanth a transitional form, and as proof, he announced it would actually walk on the bottom of the sea.
I have no doubt that this fish crawls about on the bottom quite easily.
Yes, the professor says the fish is a kind of ancestor of man. Poor fish.
But he knew he would have to find one alive and walking to prove the coelacanth was the elusive transitional form. He looked for 13 years until another one was found. And it didn't walk, it swam. It was just another fish.
Well, it was thrown out. There were quite a lot of nasty letters sent to JLB too, to say that he was having a daydream.
There was still no transitional form, nothing to show that a fish with fins had walked over land and evolved into our first ancestor with legs. Nothing to silence the creationists. And there it rested for 30 years. Evolutionists still clung to the theory that a fish evolved into the first five-fingered land-walking ancestor as a result of drought, even though they knew there was a gap in the story. But without new evidence, no one could come up with a better idea. In 1981, along came paleontology's avenging angel. Jenny Clack had long dreamed of embarking on the quest to find out why we first walked on the land. But when she arrived in Cambridge, it seemed a remote hope.
I had just finished my thesis when I started work here and was looking around for another project. And a colleague of mine said, "Don't worry, something will turn up." And I didn't believe him.
What turned up was the notebook of a geology student who had visited Greenland in 1970. In one corner, he'd made an extraordinary note that showed though he knew about rocks, he knew little of fossils. He'd written that he had found remains of Ichthyostega, Jarvik's legendary first tetrapod, of which only one complete specimen existed anywhere in the world.
He'd noted Ichthyostega bones and skull bones common. And early tetrapod specimens are not common anywhere, particularly not Devonian tetrapods on a mountain in Greenland. And to see this in his notebook just set the bells ringing. We have to go there.
By 1987, Clack was off to this apparent gold mine of tetrapods, taking along a student, Per Alberg. It was a big undertaking.
And of course it was possible that we were going to find almost nothing, or at least nothing new. So the potential was there on the one hand for a spectacular success, and on the other hand for a considerable embarrassment.
At first, it looked more like embarrassment.
As the week wore on, or the first 2 weeks wore on, we still hadn't found the locality that we were looking for. We were beginning to think, are we on the right mountain?
Then, Clack saw something.
It was covered with dirt and soil. It very nearly got thrown on the scrap heap. But fortunately, we brushed some of the dirt off and we could see part of a skull.
Clack's team had not found the transitional form between fish and tetrapods, but she had found something almost as rare. It was another species of Devonian tetrapod, a species called Acanthostaga. Different from Yarvix, but clearly sharing the same ancestry, and therefore also related to humans. Acanthostaga was only the second complete Devonian tetrapod ever to be found. Clack returned to Cambridge with dozens of tetrapod fossils. It meant that at last someone else would be able to do original work in the field of how we got our legs. But the true importance of the trip did not emerge until 1990, when a colleague, Mike Coates, started work on the specimen she'd almost thrown away, the Acanthostaga. He started to dig its hand out of the rock, and he expected, of course, to find just 5 fingers.
The first thing he found on this block was a finger, this digit here. So we've got a number of finger bones aligned along the edge of this block. Then he continued with the preparation. He found the next finger, which is here, with its end curled over. And then a third, similarly with this crooked finger end, and a fourth, again with that. And then there's a gap, and then he went on to find another finger. Individual finger bones are really quite clear. And that makes a total of 5. But he still had all this area here to prepare, so instead of stopping, he went on to clean up the rest of this area. And lo and behold, here is another digit, so that makes 6. And he expected to finish there. And then, to his amazement, here's a 7th, and finally, an 8th. What?
But it was true. Acanthostaga had 8 fingers on one hand. The very earliest tetrapods did not, as all the textbooks claimed, have 5 fingers after all. It suddenly raised the question, if the most basic assumption behind the previous 100 years' research was wrong, then what else might be wrong?
Until that day, I had assumed, like everyone else, that 5 was the primitive number of digits for a tetrapod limb. The old explanations for the origin of this structure, after all, one of the most fundamental and defining structures of being a tetrapod, and in our own way of being human, was in the bin.
Scientists now believe our earliest ancestors with legs must have started out life with numerous digits, and then evolution reduced them to 5 over the eons that followed. And the shocks just kept getting bigger. Another fundamental assumption, that we had evolved legs for the express purpose of walking, just could not be true.
If you look at the limbs, what you find is that the joints are all angled so that the limb would have stretched out just to the sides. There's just no way that it could have brought its leg underneath to take any weight. Similarly with the hind limb, which we found a bit later on, similar kind of arrangement, no ankle to speak of, just a paddle-like limb.
Acanthostaga's legs would have been useless for walking. And what's more, although it was a fully formed tetrapod, it could never have lived out of the water. It had gills just like a fish. It meant the evolution of our legs could never have had anything to do with walking on land. Jenny Clack's discovery of the Acanthostaga had changed everything. The old explanation that we'd evolved our legs after a fish came onto land just could not be true.
So the thing that has really changed is that rather than the fish going onto the land while they've still got fins, we've turned that completely on its head. So now we've got tetrapods in the water, still in the water, while they've got limbs with digits.
Stunned by these revelations, Clack decided to check her findings against Ichthyostega, Jarvik's iconic first tetrapod, a fragment of which she'd also collected in Greenland. Her team prepared the specimen and counted the toes.
7. Why didn't Jarvik see this?
There was more that Jarvik did not see. Clack discovered that Ichthyostega did not, as Jarvik had shown, have legs made for walking. They too were paddles. Jarvik had simply got it wrong, and no one will ever know why. Clack's discoveries meant the whole quest as to how and why we had evolved limbs would have to start again. Now they didn't just need the transitional form to link fish to tetrapods, though that was still missing, but they also needed a whole new reason why limbs had evolved. Why would any creature need legs that weren't for walking? In a valley bypassed by the American dream, they would find the answer, the real story of how we got our legs. Renovo, Pennsylvania, is what happens at the end of the railway line when the trains don't come anymore. But the town is rich in something rare and precious. Beneath the trees are swathes of red Devonian sandstone. So in 1993, along came a lone fossil hunter. He's called Ted Deschler. Deschler made his name finding 2 more new Devonian tetrapod species in a roadside cutting called Red Hill. But the thing that took both him and Red Hill into fossil hunting legend was when he examined one of the site's peculiar features. In amongst all the red rock was a broad green layer.
Okay, majority of the rock out here at Red Hill, of course, is red. Climbing up through sandstones, siltier sandstones and mudstones. But right into this zone up here, we start with a green layer. It's reduced, probably because of all of the plant material that's buried within the rock here.
Fossil plants. By finding them alongside Devonian tetrapods, Deschler had made a vital breakthrough. He could now reconstruct for the very first time the true environment in which the first tetrapods had evolved. The Devonian wasn't the barren, treeless landscape spoken of in textbooks. It was more like a rainforest.
The most common thing we're finding is a tree-like plant. It actually has a long, tall trunk, and some people say these got up to 30 meters tall, so these were truly the first canopy sort of producing plants. We also find fern-like plants and a variety of other things. And so we're really seeing a diversity from a site like Red Hill. And I think it's important because it's showing us that these were actually complex environments.
The textbooks had got it wrong again. The Earth may once have been barren, but by the end of the Devonian, it was very, very wet and densely forested with huge permanent rivers. These were bordered by something completely new, swamp, that gray area between land and water. The first tetrapods had evolved in this wholly new ecosystem. precisely the kind of thing that could indeed be a spur to major evolutionary change.
Oh, it's completely new. By the time you get to the end of the Devonian, for the very first time in Earth history, animals and plants are living on land in a significant, permanent way. That's brand new. And a lot of open niches in that, waiting to be exploited.
Those new niches were the margins of this watery world. In the tangle of vegetation, limbs with fingers would have given tetrapods a unique advantage over fish.
I think we have to think of these fins or limbs or flims as something that would be used by the animal for moving through more complex environments like swamps or environments where there may have been trees down in channels or just shallow water to pursue prey or to escape the guy who's trying to prey upon you.
And there was most definitely something from which to escape. Over and over again, Deschler and his team found evidence of a fish called Hyneria, a predator of terrifying proportions.
Hyneria is the most common lobe-finned fish at this site. It's also the biggest. It's probably 2 or 3 meters long. This is a single tooth from a large Hyneria, and these were carnivorous, obviously. When you see the early tetrapods in the same fauna with these Hyneria, it really does make you think, well, maybe escaping from large predators like this Hyneria was a pretty important thing for these early tetrapods.
The mystery of why we had evolved limbs was finally solved. They were not for walking, but navigating through swamps, just like this hellbender salamander does today. But there was still a hole in the story. There was still no fossil that showed the process of change from fish to tetrapod actually happening. The transitional form, something half fish, half four-legged animal, was still missing. And then, Per Ahlberg made his fateful visit to Latvia. In that forgotten museum drawer, he may have found what everyone had been looking for. His trained eye told him the fossil was a fragment of jaw, right from the time of transition, and it was certainly part fish and part tetrapod.
The information we get from this one paltry little bone is quite overwhelming.
He named the jaw Livoniana. And to prove it really was a transitional form, he ran it through something called a cladistic analysis. A computer is programmed with all the anatomical features that distinguish fish from tetrapods. Some are obvious, such as, does the specimen have limbs or fins? Others are tiny shifts in the position of blood vessels or bones. Such minute details allow scientists to identify a creature from just a fossil fragment and place it in an evolutionary tree relative to other animals. For this comparison, a lobe-finned fish jaw is on one side, Livoniana is in the middle, and a Devonian tetrapod jaw is on the other side.
What you can see, if we look at the endpoints, is that these two jaws differ in quite a lot of ways. First of all, if we look at this pit in the fish's jaw, which is a particularly important feature, a deep hollow that goes all the way through to underlying bones. The bone you're getting in the bottom there is a different one to the ones that are coming up on the surface here. In Livoniana, that's the same place. The pit has almost disappeared, surrounding now a blood vessel hole here, which we didn't have in the other jaw. If we look at the tetrapod, we have the pit now gone altogether, and here's that lower blood vessel hole there in the tetrapod. So in this respect, Livoniana kind of agrees with the tetrapod. On the other hand, we find that in the fish, a bone from the outer surface of the jaw comes down to here and ends, and it abuts against another bone up here called the prearticular. In the tetrapod, the bone from the outer face comes all the way up here. It forms a big tongue extending backwards, and it comes all the way up here beneath it. So quite a different arrangement. Livoniana here has got the junction and the bone exposed on the surface, just like the fish. So in this case, Livoniana agrees with the fish. So as you can see, depending on which characteristic you look at, it either lies sort of halfway between, or it agrees with the tetrapod, or it agrees with the fish. Exactly what you would expect from an intermediate form.
Ahlberg believes Livoniana really is an elusive transitional form, almost exactly half fish and half tetrapod. It is certainly the only fossil yet discovered that shows the process of change between the two actually taking place. It also has one freakish feature. There are 7 rows of teeth. It is unlike any other creature we know of. This suggests it must be one of the host of mutants that made this change, just one of which would eventually become our ancestor. Livoniana is a real missing link. Darwin's 360-million-year-old riddle about how we developed our legs has been solved. It was vegetation, on land and in the water, that let flourish an explosion of mutations among lobe-finned fish. The most successful of these mutations, the one that stood the test of time, was the development of limbs with fingers and toes. It was out of this swampy area that our earliest ancestor came crawling over land. It was not preordained, but chance. A series of evolutionary accidents. But it just so happened that that creature's children would indeed inherit the earth one day.